हरिः कर्ता।
Now let's try to demonstrate the advantages of NumPy arrays using the comparison with the standard Python sequences. Okay, for that let's get into our Jupyter notebook. So just open your Jupyter notebook at the location wherever you want. I hope you know how to do that. And once your Jupyter notebook dashboard is up, then you can just click on new drop down icon and then click on Python 3 and you just name it. Name this editor. This is Jupyter notebook editor. I'll say NumPy begin. So the points about sequence size and speed are particularly important in scientific computing. So let's take a simple example. Let's consider the case of multiplying each element in a 1D sequence with the corresponding element in another sequence of the same length. Okay, so let's take two Python sequences, which is two lists. List A, I'll take list of range of 1 to 5, and another list of range of 1 to 5. So my two lists are ready. Now I just want to multiply each element. Let me see, A and B. So I want each element, corresponding element in A with B should be multiplied. 1 with 1, 2 with 2, 3, 3, 4 with 4. Okay. So now if the data are stored in two Python lists, A and B, so we could iterate over each element. So for that I'm going to use a for loop. So but the new sequence, the new Python sequence, that is list that we get, should be stored in some variable, should be assigned to some variable. So that's the reason I'm mapping that new list that we are going to generate from the corresponding multiplication to the C. So I'll put an empty. So then after that I'm gonna use a for loop. For is our keyword, E is iterative variable, in is membership operator, then range of length of A, then C, and append the result of following operation. So what I'm gonna do, A of I, sorry, indexing times B of I. That's it. And let me look into C, and here is that 1 times 1, 2 times 2, 3 times 3, 4 times 4. So this is how we do that. But this produced the correct answer. But if A and B each contain millions of numbers, what is going to happen? We will pay the price for the inefficiencies of looping in Python. Let's see. Let me take this time. Let me scroll up. 1, 2. Okay. And same thing, I'm going to put it here. execute both. So Python is Python int too large to convert to C size. That's what happens. So let me remove some. This is also too large, and this one, yeah, this one is pretty better. So that's where I just want to prove it can't even take. But in a real scenario, what you will find is a sequences with huge millions of elements in it, millions. The size the size would be too big. The size would be too big. So that's what. Okay. Okay. So it's gonna take huge amount of time. It will do, but it's gonna take huge amount of time. And in some cases, it's clearly mentioning that if it crosses some level, so the Python can't take. Let me put two more zeros. It's fine. Okay, that's it. So a list range one, it's memory error. That's where it end up. Okay, it's a memory error. List index out of range. So this is where we have to pay the price of even it got struck. Okay, this is where we have to pay the price for the inefficiencies of looping in Python. So we could accomplish the same task much more quickly in C by writing it clearly. So like if you use a C programming language and similar one, we can do it much fastly and much quickly and much efficiently. So that doesn't mean Python is inferior, but the Python fun inbuilt core sequences are inefficient for certain tasks of work. That's what I'm trying to say here. I'm not saying that Python is inferior than C. So basically that actually saves if you do the same activity and in C, it actually saves all the overhead involved in interpreting the Python code and manipulating Python objects, but at the expense of the benefits gained from coding in Python. That's where it will. Okay. So furthermore, the coding work required increases with the dimensionality of our data. So now we have seen just 1D, one dimensional. But if you go for in the case of a two-dimensional array, for example, the C code, let's take if it is a two-dimensional array, so the C code would be much complicated. So to do that, it would be much complicated. So then comes the NumPy. So NumPy gives us the best of the both worlds. So I'll type that because it makes a mathematician's life much easier. NumPy gives us the best of both worlds. So element by element operations are the default mode when an n-dimensional array is involved. But the element by element operation is speedily executed by the pre-compiled C code in NumPy. So NumPy uses the benefits of that's a fast compilation of C and a coding features, a simple coding features from Python, and brings up the benefits from both worlds and makes our mathematicians and statisticians and data scientists life much easier. So So in NumPy does like what the earlier example we have discussed, the same examples, whatever we have discussed so far, even if it is a millions of data points, still NumPy can do it with an ease.